A natural question to ask when you're looking at this diagram is this an alternating current system or is it a direct current system? And the answer is it's got components of both. For example, the battery and the solar panels are both direct current, whereas the rest of the system is primarily an alternating current system. Before we get too far, we should define what direct current is and what alternating current is. So we'll do a side-by-side comparison. On this side, we'll show direct current, and on this side, we'll show alternating current. Now in both cases, you could think of these as simple mathematical functions. For direct current, it goes something like this. We have a function with time as its input, and in the case of, say, our solar panels, the voltage is 1200 volts. If we were to plot that out, it would look like this. We would have time on this axis and voltage on this axis. Here, f of t is equal to 1200, which means for all time, the voltage will be a constant 1200 volts. Now contrast that with the alternating current system. Here, again, we have a function of time, but this time it's going to be sine of 2 pi f t. And here, f is the frequency of the system. Here in America, that would be 60 hertz. When we make a plot of this function, it looks like this. Once again, we have time marching this way, and then we have voltage. This is 0 volts here. And then we can plot the sinusoid, which would look like this. Again, with the frequency of this particular waveform being 60 hertz. When you look at these drawings side by side, you might be reminded of one of the devices you saw on our diagram at the very beginning of this presentation. And that was our power converters. It would convert direct current into alternating current. And now you can see where these symbols came from. This looks a lot like that symbol there, and this looks a lot like that. I got to tell you, these DC to AC converters are my favorite technology. Let's put the battery back in and see how it operates. We said that the battery provides a backup power source. That means power can flow from the battery and get transferred from DC to AC. But the battery also needs to be charged, so when power is available, say from a solar generator or hydro, the power can flow back this way through the converter to charge the battery. So this device can be a DC to AC or an AC to DC converter. Later on, I hope to talk about the technology that's inside this converter. It's actually computer controlled and very sophisticated in what it can do. We said that the rest of the power grid was based on AC. And I want to give a quick example of why that is such a powerful tool, and we'll use the pumped hydro as an example. The pumped hydro system has several machines, and these machines can act as either pumps or motors depending on which way we want the power to flow. Either way, the shaft is rotated and we convert mechanical energy into electrical energy, or vice versa, depending on which way we're pumping the water. This machine is connected up to a power converter and then another power converter. So here we convert alternating current to direct current and direct current into alternating current. And this is interesting, and it shows you how there's alternating current and direct current in the system. But what I really wanted to talk about was the transformer. And we will draw the transformer as two linked circles like that. If you've studied electronics before, you may have seen transformers that look like this. But just know that they're the same thing. Now, the reason we need transformers is because this wire is long. That pumped hydro system is 5 miles away from town. In order to make the system work, we had two choices. We could install really thick wire, or we could run low current, high voltage system. And that's the beauty of the transformer. You can take a voltage, such as 4160 on this side, and you can step it up to 25 kilovolts. And then you send it over this 5 miles, and when you get to town, you can drop it from 25 kilovolts down to whatever you need to distribute for the town. And it's these transformers, which only operate at AC, that allow us to do that. So there you have it. Our system has both AC and DC components. For reasons we'll discuss later, we have these beautiful power converters that allow our motors to run at variable speeds. And we've got converters such as this on our batteries that allow us to both charge and discharge the battery.